Okay, we are back again. I hope you are ready for the next set of presentations that come under a common title, Recent Advancements in Language Technologies for Serbian. And our first presenter will be Professor Ranka Stankovic from the Faculty of Mining and Geology, University of Belgrade. And the presentation will be about the corpus of contemporary Serbian version 2021. Dear colleague, it's my pleasure today to present a joint work of a much larger team led by Professor Duško Vitas and one team that comes from University of Belgrade from several faculties, all joined in Jerteh Society for Language Resources and Tools. I will start with brief historical overview, then we will see what is new in our resources related to corpora. Then we will see some statistical overview, what is the current state. We will see something about corpus preparation pipeline as we are using now, and some advanced query expansion architecture. Related to the content, we have a very large variety of text and corpora for Serbian. They vary both in types and in levels of annotation. And when we speak about level of annotation, we have some raw text, some are post-tagged, some are lemmatized, full, some are with the full morphological and or name entity annotation. Variations are also related to the structural annotations. Some of them are TEI compliant. When we speak about balancing, two corpora are that are available for search are balanced to a certain extent with the aim to represent the language in general, and they are developed by researchers from University of Belgrade and the Jerteh Society, as I already mentioned. First corpus that was available online is SRP Core 2003. It is 22 million words. It was a collection of annotated text, unannotated text with bibliographic descriptions, and it is available since 2003, and it is used by approximately 300 registered users. Next, much larger corpus of contemporary Serbian is 122 million words. It is annotated with part of speech and lemma. It is published on EMS CQP corpus management system, and at the moment has more than 800 registered users. One subset of that corpus is available for download and distributed under CC BY and NC license. Here you can see the URL where you can have more information of this corpora. A few months ago, the new version was compiled with the text that were collected during this time, not during 2021, but the years before that. And the new corpus at the moment have 600 million words new text, so that are not included in Serbian corpus version 2013. It is lemmatized and it is post-tagged using both universal dependency tag set and traditional Serbian text tag. In this corpus, we have newspaper text, literary text, textbooks on various topics, PhD theses, and other texts from various domains. In addition to this corpus, we have also corpora, one corpus from Wikipedia and several much smaller domain corpora available. Corpus management system that we are using is Sketch. It's an open source version of Sketch engine, and online access is available at this URL. As I mentioned, various domain corpora from mathematics, mining, geology, etc. are published. The new system for preparation and management of corpus enables us for permanent enhancement. So we hope that we will not wait several years for new version. We would like to continually update our corpus. Some parts of corpus are open for browsing without any registration. So it is Wikipedia corpus and the Serbian alter corpus. Later will be more information about that. Other corpora parts are available for registered users. One part for mining with selected text are available for download. We had to exclude some textbooks that are under copyright and some mining projects with sensitive data. Here you can see this corpus that is available on the European language grid portal, and we will apply similar approach to open other data with excluding sensitive data and copyright data for other domains like power engineering, librarianship, agriculture, etc. Here you can see statistical overview in tokens, words, and documents for corpora that are currently published on our URL. And when we speak about text styles, here you can see the version in percents. Version of Corpus 2013 and the new one, but also last column gives figures related to total amount. And you can see that now we have slightly better balance between these styles. One you have to have in mind this is a very rough approximation. The style is determined according to the source of text, but some, for example, in some newspaper, we can have some literary text, but anyway, they will be here classified as newspaper. Related to the some kind of improvements in preparation for corpus, we made one in-house web application to automate the process of preparation for corpus. So we have some kind of pipeline for transformation of resources from their original form into the final form required by the corpus management system. This web application combines many tools: metadata management, text processing, including transliteration, Cyrillic Latin, transformation with this different XML schema, JSON, etc. Then tokenization tools, analysis, which we used to estimate unknown words as, in some text, then lemmatization, post-tagging. Here you can see the tool used for lemmatization. It is Serbian morphological dictionaries for tagging, available on European. We have published them on European language grid, and they are derived from well-known Serbian morphological dictionaries that are also available on ELG portal. I mentioned two post-tag sets that we used. Here you can see tags for universal dependencies and tags for traditional Serbian. We also included a special service related to query expansion architecture besides the usual SQL queries using lemmas, word forms, and part of speech. We implemented a Vibrant service which can expand our query to include synonymy, derivations, hyperonymy, etc. And by consulting morphological dictionaries, by consulting semantic networks, WordNet concrete, and some terminological databases. Expanded query is sent to CQP, CQL, and further processed by corpus management system. Here you can see one example of integration of our developed resources. I think a very interesting integration between lexical base Leximirka and the term base Termi with corpus data. On the left-hand side, you can see the screen from Leximirka, and one part that was derived from different corpora is frequencies, and the user can see frequencies from derived from different corpora. Also, it can submit a query directly from Leximirka directly to corpus and retrieve concordances, form frequencies, lemma frequencies, and also some patterns, lexical patterns can be submitted as queries. Here on the right-hand side, you can see a frequency for one such pattern. Same functionality is available for term-based. Here you can see računarstvo as in term-based with the definition and with the concordances and frequency in corpus. Thank you for your attention, and here I can offer you some publications for further reading on these topics.
Thank you, Ranka, for this presentation. I will encourage you again to type your questions in chat, and presenters will answer them at the end of this session. Now we have the next presenter, that is Biljana Rujević, also from the Faculty of Mining and Geology, University of Belgrade, and she will talk us about this system Leximirka that Ranka already mentioned, lexicographic database and application.
Thank you very much. Okay, I will share the screen. Can you hear me?
Yes.
Can you see my screen?
Yes, we see your screen.
Thank you very much. Thanks. So this is the presentation on electronic dictionary that has been reshaped by database and an application intended for human use. In the first part of this presentation, we are going to talk about transformation of Serbian morphological dictionaries from the form of textual files to lexical database. The second part is going to be about web application Leximirka. We will present basic information on its segments. The third part is going to be about user profiles in the application. We'll see a very short demonstration on the same lexical entry from different user perspectives. And at the end, we'll see information on 2 papers for those who want to know more about Leximirka. Serbian morphological dictionaries are electronic dictionaries that represent a significant resource for Serbian language processing. Their importance lay in the fact that Serbian language is the language with rich flexion. Professor Cvetana Krstev and Professor Duško Vitas start working on the development of Serbian morphological dictionaries more than almost 30 years ago. The importance of this resource is in its multiple applications. They were initially developed for Unitex, that is open source corpus processing system. But besides Unitex, these dictionaries can be used in various NLP tasks. They were used for word processing, automatic recognition of terms, advanced search on text repositories and digital libraries, etc. The morphological, they consist on general lexica, proper names, general knowledge, and also domain terminology. The morphological dictionaries were developed in DELA text format. A dictionary of simple words, DELAS, contains more than 205,000 lemmas with more than 207,000 senses. Dictionary of compounds, DELATS, contains more than 2,200 thousand lemmas with more than 2,300 senses. Before Leximirka, all types of dictionaries were stored and used in form on textual files. Before Leximirka, for many years, the dictionaries were maintained with the help of desktop application Leximir. And before Leximir, application workstation for lexical resources was used. As dictionaries have grown over the years in terms of the number of lexical entries and dictionary files, but also in terms of participants who have assist in their development, a need for more efficient system emerged. So we decided to develop the new application based on database. While choosing lexicographic database model, care was taken to standardize the data from the morphological dictionaries and to make them interoperable and reusable. We considered three standards for lexical information: TI guidelines, a lexical markup framework, and the Lemon model. Our decision is a database model based on Lemon, but some modifications and extensions were necessary to enable full migration of complex grammatical structures and numerous inflected forms for Serbian. In this figure, we can see the representation of lexical data from DELA's lexical entry within the database model. The boxes marked blue contain data from DELA's lexical entry, COSA. The lex properties table is used to store the values of markers assigned to a lexical entry level. Information about complete lexical entry, about lemma, part of speech, and morphological class is in the lexical entry table. Inflective class information is in the morph pattern table, while the information about dictionary to which the lexical entry belongs is in the lexicon table. For one entry in lexicon table, that is one dictionary, one or more records of the lexical entry table are connected. This means that one or more lexical entries are part of one dictionary. The senses of lexical entries are placed in lexical sense table, which the individual categories that define the meanings are placed in a lexical properties table. A single representation of lexical entry table can have multiple senses or be related to multiple lexical sense table entries. That is the case with our example. A lexical entry COSA has three meanings. It is hair, defined by domain marker anatomy. It is also a slope in domain of geology, and it is also the tool for the grass cutting, defined by semantical marker for instrument. Green and yellow boxes contain additional information that was not recorded in textual version of DELA's dictionaries. The left frequency table shows that word COSA is among 50,000 most frequent words in the corpus of the Serbian language, SerbCorp. The lexical relation table stores information about relations with other entries in the same database. In this case, this table contains information about an established relation with lexical relation Kosica, that is small hair, called the diminutive, as well as the description of the rule for establishing this relation, that is a-ica. It means that suffix a is going to be replaced with suffix ica to establish this relationship. If we talk about benefits of the lexical database, it gave us possibility for advanced search and better data category control, but also it enabled the establishment of lexical relations between lexical entries. In general, we achieved three types of lexical relations: relation between Ekavian and Yakavian pronunciation, variations, and derivation relations. Lexical database also enabled linking to lexical entries from different external lexical resources, for example, BabelNet, Wiktionary, Termi, and Glossbe. It also enabled linking to lexical entries from dictionaries stored in a local database. For example, Serbian WordNet, Terminological Dictionary, etc. Application Leximerka is available on web address leximerka.jertek.rs. Complete application consists on 7 segments. Category segment gives an overview of all the data categories. File segment contains metadata about individual dictionary files, adding new one or exporting individual dictionary files. Entries segment serves for adding new or added existing lexical entries, search them by lemma or data category markers. Segment corpora contains metadata about available corpora that are searchable by lemmas. Evaluation segment enables the evaluation of the automatically obtained list of candidates for dictionary entries. A relation segment should be used for managing a set of rules necessary to establish relations between pairs of lexical entries. And a morphology segment stores metadata about morphological patterns that are used in morphological dictionaries. In this slide, we can see data category segment. This board provides an overview of all the data categories in a 3-level hierarchical form. User with highest level of privileges can edit the existing categories or add the new one that will be used in the dictionaries. In the left part of is category 3 with selected category domain. In the right part of the board are information on that category. We can see ID of parent category, label on this domain category, and then we can see the name, profile, description, and examples. In the for adding a sibling category and child category, we can use those 2 green buttons, and also in lower part we can see values for this data category. For example, it is domain marker of agro for agronomy, domain marker for anatomy, etc. Now we will talk about user groups in the application Leximerka. In general, we can distinguish 3 levels of users. The first level of user can search through 100,000 of the most frequent words in Serbian corpus and see lexical entries in a public view. The second level of user can search all lexical entries and see all the information, including category values, and perform the corpora search. And what is important, he can edit lexical resources. This user has search limit set to 12,000 characters. The third level user can do everything like the second level user, but without a search limit. Additionally, he has access to application management board. In this slide, we can see lexical entry mineral, which is mineral, from perspective of first level user. It is used user who just registered account on Leximirka. We can see relations of this lexical entry. It is connected to lexical entry mineralan, using relational adjective, and mineralizacija using noun process. Data categories in sense part are given in form on natural language. As you could see, you will see the next level user, where this part of information is shown in data category values. So if we take a look on this slide, we'll see the preview of the second level user. He can see all flective forms of this word. You can see it here. More dictionaries than from the local database. He can search available corpora by lemma mineral, or he can also use predefined patterns like adjective followed by noun, mineral, etc. He can also check concordances from frequencies and lemma frequencies in a specific corpus that can be choose here. And this is the same entry in mode for editing. User can choose a morphological pattern from drop-down list. Adding properties is possible by typing value in search field and pressing the loop icon that is squared in pink. After choosing adequate value, adding is possible by clicking on this green plus button. So that's it. So to conclude this presentation, Leximirka is application for managing, developing, and browsing Serbian morphological dictionaries. And we hope not only for Serbian dictionaries. Leximirka database is language independent. French morphological dictionaries testing is currently underway. As you could see, the enriched morphological dictionary can be used not only for natural language processing, but also it can be used by humans. And at the end, for more detailed information about Leximirka, you can read these two papers. Thank you very much.
Thank you, Biljana, for your presentation. And now we can proceed with our next presentation and our next presenter. Our next presenter will be Mihajlo Škorić from the Faculty of Mining and Geology, University of Belgrade. And the presentation will be about deep part of speech taggers and the old novels. Please, Mihajlo.
Hello. Today I'll be talking a little bit about some advances in part-to-speech tagging for Serbian, some different part-to-speech tagging methods and tools, and some possible exploits of resources. So first of all, what is part-to-speech tagging? So-called post tagging. It is one of the basic tasks in natural language processing, and it is the most common case of token level annotation, where each token in a document is labeled with a category. And since this is a good case of showcasing classification in general, an abundance of methods and tools have been tested through years. So each time a new classification method emerges, several part-to-speech taggers based on that methods are created. Mostly there are three different types of post taggers. First is rule-based, which are based on dictionaries, linguistic rules, and lookup tables for those dictionaries. Then there are stochastic-based taggers based on different machine learning technologies, hidden Markov models, naive Bayes, support vector machines, and most recently and most popularly, recurrent neural network. And the third option is, of course, the hybrid one, a post tagger, which combines the other two methods. So here we have listed 5 taggers, which we believe are the most commonly used today. There is a tree tagger, which is a hybrid tagger based on looking up a lexicon and hidden Markov models. So it's a fairly simple machine learning technique combined with a rule-based approach. Then there's a RNN tagger, which is it's tree tagger's a bit lesser known cousin, made by the same authors, which doesn't use the lookup tables, but only uses the recurrent neural networks. Then there's a natural language toolkit, which actually gives option of using multiple different methods. Then there's Stanford NLP, recently rebranded as Stanza, which now uses recurrent neural networks and also combine them with dependency trees and word embeddings. And finally, we have listed Spacey, which is the most recent on this list, and it uses a recurrent neural network, and it brags about being the open source industrial powered natural language processing tool. So is there the best option? There isn't actually. Each of these taggers come with its pros and cons. So, and here is a simple case study we conducted some time ago. And here we are looking at results for tree tagger and RNN tagger that are trained on a mixed corpora, 90% of it, and we tested on 10%, which is the far left bars. And you can see that RNN tagger in orange outperforms tree tagger in this case. But when we go to the second corpora, which we tested it on, which is history, they are already performing the same. And when we move on to the here, it's dubbed LTEC, but it's actually the corpora of all Serbian novels. Tree tagger actually outperforms the RNN tagger, and this effect is even more pronounced in the bottom chart, which which is the same test, but with a grained post-tagging, a bit more difficult task. So we came to a conclusion that these RNN-based taggers outperform lexicon-based tools only when there is a high percent of overlap in tokens between the corporate was trained on and the documents it is tested on. And in this case, all Serbian novels contain an abundance of words which are not found in the training data set it was used, but they are found in the lexical dictionary which TreeTagger uses as a support. So the next question, why can't we combine them? Well, we actually can, and people have done it for years. Some of the most popular methods of combinations are, well, for starter, there's basic voting, where each tagger is picking a single tag for each token, and then the tag with the most votes actually, so to say, wins. But the problem with this approach is that there is a very high chance for a tie, and it doesn't work at all if there are two taggers which are being combined. For example, here if we have a TreeTagger and RNN tagger, if one says one thing and the other says the other, it's a tie. That's why weighted voting was introduced, which gives a certain weights to certain taggers, and it helps in resolving ties. But more advanced techniques in combination of tools are based on probabilities or other scoring types. So there's bidding, where each tagger assigns a probability to each tag for each token, and then the tag with the highest probability is picked. Then there is a scoring, where the probabilities among taggers are summed up, and the tag with highest score gets to be the label. And the maybe final one in this group is stacking, where another classifier is trained on top of probabilistic outputs of taggers in order to produce a single output. And the main maybe advantage of this approach is that the tag sets that are being used among taggers don't have to necessarily overlap in this case. There is no summing, there is no bidding, so it is left to another classifier to pick the final solution. And of course, there might be other combination methods which are not listed here. So if we definitely decide for a combination method, what is the best method to maximize the results? And it is most probably cranking up the number of different taggers. So if you have more and more different tools, there's a higher chance of getting a better combination, especially if you're using stacking, which learns not to use unreliable taggers. It diminishes its input. But of course, all taggers being used have to make different predictions in order for this to make sense. So we previously listed 5 taggers, but there comes a question: how can we extend this domain? How can we get more taggers? Well, we can do it in some artificial ways. First, there's transfer learning. For example, if you have a corpora annotated with multiple tag sets, it can be used in, if you are using stacking composition, it can be used to train if you have n tag sets, you can train a number of taggers times n taggers. So if you are training 3 tagger and RNN tagger, and you have 2 tag sets, you can get 4 taggers using this method. And there's another approach is, so to say, data set augmentation, where you augment the data set in order to force taggers to output different results. And here is my my personal favorite method, and it's training taggers on inverted data set. So basically, if you have a data set, training set, let's start there. You can invert it, then train each tagger on an inverted data set, and those taggers will perform just fine as long as they're receiving an inverted input. So if you are trying to tag a sentence, you are passing that sentence to normal taggers, and then you invert it and pass it to the inversely trained ones in order to get different opinions, so to say. And yes, we are already doing this. We are already training these bidirectional taggers. We are already having a stacked architecture. A Python package is published. It is currently named bstagger, standing for bidirectionally expandable and stacked tagger. And we published some resources for this one. It was trained on, I'm not sure if it was previously mentioned, this SERP core for tagging corpus, which is available on European language grid. And we trained 2 different taggers, 3 tagger and spacey, and we trained them both normally and inversely in order to produce 4 taggers. So if you download the SERP core for tagging 3 tagger, for example, you'll receive 2 different models, one trained on normal data set and one trained on the inverted one. And same goes for spacey. We mainly pick these 2 because they seem to work. They have the highest rate of accuracy for speed. Yes. Oh, and this is the link to the tagger, which you can use to train new taggers, and you can train a stack classifiers on top of them and use it. So this package comes with training, tagging, and also testing capabilities. Yep. And if you want some more information on comparative study on different taggers, you can check this paper out. And that would be it from me today.
Okay, thank you, Mihailo. I hope this was interesting for our audience. I'm sure it was. And now we are going to our next presenter. Our next presenter will be Branislava Šandrić-Todorović, and she will talk about the platform called NER and much more beyond. So it is something about NEM entity recognition.
Thank you. Let me share my screen.
We see you. We see the presentation also. So you can start, Branislava.
Okay, thank you. So as Professor said, my name is Branislava, and I'm today going to briefly guide you through our past and current activities regarding named entity recognition. So the presentation is called net and much more beyond, not by accident. We actually have developed a web application that has exactly this name. So what would be the outline of my talk today? I will present you this web application, and basically it contains 4 different panels that have different purposes. So mapping, conversion, models, and evaluation. And I will also show you what we have published so far related to the image recognition. And if you're interested, you can take a look. So the platform can be found on this link, Never Beyond. And why have we developed it? Well, we simply have noticed that we need different tools for every step we take. We need to train different models, also for evaluation. So we came up to the idea to simply have this. If you go to this URL, you can also find there is a very detailed user manual, and you can also find tutorials on YouTube. So this is the link to the channel. What we also find convenient that if you decide to use this web application, you have some NER-related activity and you would like to make use of this application. If you're not certain what should you expect from the output, there are sample files. So for each of the option, there is a sample input, and then you can try out the option. And so let me show you over here. I'm not sure if you can see my cursor. I think you can. But for example, this is the first panel. And this is the uniform in every panel. You can see here on the left what is the expected structure of the input. So let me show you first what does this first panel do. So either we want to do some evaluation or something else. And let's say we have a text collection with one tag set, but we need some other tag set. So we can upload 2 collections containing different tag sets and simply map the tag set that we don't want to. We can rename those name entities, map them to the corresponding entities that we need. For example, let's say we have a text collection with these fine-grained entities, so dates, events, language, locations, different person names, and so on, but we need simpler text sets. So we want to keep only named entities that contain location, person, role, and so on. So we can, with this corresponding naming convention, upload our text collections and then say, okay, so I want to keep this entity, I want to remove this entity, I will just keep this one, not do anything. And I don't know, for example, I will all these person, their entity, and so on. So this is something we call the mapping panel. Okay, so when we are working with different name entity recognizers or different, I don't know, platforms for annotation and so on, it's very common that there are 3 standard text formats. So either sometimes we use XML, sometimes we need the so-called standard format, sometimes we have the verticalized CO and LL format. So we created this conversion panel that enables us to map from one format to another. So basically, it's possible to perform mapping into any. So any combination is possible: XML to standoff, standoff to CONL, or back to standoff, back to XML, and so on. So this would be the second panel. And then the next is something that is so contains the models we have trained so far. So first, back in 2019, we have experimented a bit with the, let's say, more traditional models, so specifically with conditional random fields. And we have trained two name entity recognizers, so the Stanford there and the Spacey. These models can be assessed here with within these two options. So, for example, for the Spacey, user can upload an archive with raw text files or even XML files, so we have actually multiple languages here, but you can find more information also about our model and for English. And so user can upload an archive with these files, select language model, and as an output get the text with annotations that were obtained by using this model, either in standoff or in XML format. And this the same applies for the Stanford NAIR. So regarding these models, I will tell you now a bit more about them. So as I said already, back in 2019, we had the so-called gold standard. We named it Gold PERS. It was a text collection that contained short news that were published on the web, mostly by either daily newspapers, news portals, weekly magazines. It had around 300,000 tokens. And how was this preparation procedure of this gold standard? So we took this text, and first we run our existing lexicon-based and rule-based SERP-NAIR. And I will show you later the paper where you can read about it. It was developed by Professor Kirstev and others. And so this was the first step. And then the second step is that we now showed this annotated text to the annotators with corresponding guidelines. And then the annotators went through it once, twice, even 3 times. We actually obtained the platinum standard. So we obtained the text that is really, really finely annotated, what we found correct. So what were the entities that were annotated? Well, personal names. So in this iteration, this first iteration, we had only personal names, but in 4 flavors. So the first model contained only, but all personal name entities, annotations. Then the second model with every of these personal named entity, it contained the information whether it's the first name, the full name, or the last name of person. Then the third model contained all these named entities and the role name entity. And finally, the fourth, the most complex model, contained 9 different named entities. So with every person name, there is information whether it was the first, full, or last name, and also the gender information. So this was the first experiment, and then last year we again conducted an experiment. Now we had a slightly different, well, not slightly, quite different text collection. So it's the Serpeltek. It's the collection of all the novels developed within the distant reading class section. We'll hear more about this later. And the size was about the same, so around 200,000 tokens. The procedure was quite similar regarding the preparation. So we first used the existing lexicon and rule-based Serpner. We asked for help, annotators' help, and then we trained the so-called Srp CNN. Why? Because it's based on convolutional neural networks. For this purpose, we use this actually again Spacey. Spacey is the, as Mikhail already mentioned, is the Python's module for so-called advanced natural language processing. This time we had a totally different text set. So beside the personal names, we also had information about role, location, organizational work, events, so on. And we obtained quite satisfactory, well, there is always room for improvement, but F1 score of around 91% on the test set. And what is also convenient is that, you can, anyone can assess these models and also have visual annotations of the text of the annotations by these models. So for example, if you go to this ner.jartech.rs, you can you can paste your text in Serbian Latin and choose from this drop-down menu which model would you like to test. And when you click on Perform Net, you can here see this text, but with emphasized these entities. And also, for example, because this is the model that contains so the information about personal name, so you can see also different variations. And regarding the annotation, we experimented a bit. So first we used Brat tool for online annotation, and since last year we are also using Inception tool. So both of them can be found on this address, on this URLs. The lastly mentioned models, Srp CNN, can also be found on ELG. So this is the address, can be downloaded and used within Spacey. And also it can be used as a web service. So you can also try it out online. There are instructions how to use it as a service or how to run it within a Python script. But for example, if we input this text and say try out, it recognizes that. So this is a sample text and the annotations of name entities. And the final panel is the statistics panel. So statistics evaluation, simply we want to see. So we run our models and we have some text with annotations. So how good are we doing with respect to the gold standard? So we have implemented first option just gives us different statistics. So like different distribution, token distribution, name entity distributions, and so on. And the second panel uses the existing tool called Gemini that also visualizes. So we input our texts that were annotated by some model and the gold standard, and it shows us which name entities in an HTML file, which entities are well recognized, which were partially recognized, which were missed, and so on. So you can use it also within our web application. And for the end, so these are the publications. I mentioned the well-known, so long existing Serb-NER, so you can find it in this, you can read about it in this paper, and more about our NER and beyond and other activities related to annotation of name entity recognition, actually in Serb-ELTE collection in these papers. And this would be it. Thank you for your attention.
Thank you, Branislava. Thank you for this presentation. And now we are going to our last presentation today. Well, I will be the presenter with the help of my young colleague, Milica Ikonić-Nešić. And this presentation will be about this corpus that we have mentioned several times before, Serbian ELTE, a corpus of 100 and more novels for reading, analyzing, and training. Okay. So I will tell you something about this, what is ELTE, and what are the formats and annotations used for this corpus, and especially about the Serbian part of this ELTE collection, and how can it be found in the outside world, and of course something to read more about this sub-collection. So what is ELTE? ELTE is an abbreviation from European Literary Text Collection, and it is being developed in the scope of the distant reading for European literary history, that is the COST action, started in 2017, and it will end this COST action this year. What are its main objectives? Well, one of the main objectives is to create a large benchmark corpus of literature from the period 1840 to 1920. And it is a multilingual corpus containing novels originally written in one of European languages. Ideally, each language sub-collection should contain 100 novels. And what are these 100 novels? What is it? Is in the corpus. First, there are some eligibility criteria. Only novels, novellas, or longer stories are considered if they have at least 10,000 words. Then they have to be published for the first time in Europe between 1840 and 1920. And they have to be written originally in the language of sub-collection. So translations are not considered. But texts are not randomly chosen. There are also some balancing criteria. So novels should be equally represented according to their size in number of words. So there should be short novels as well as long novels. Also, according to year of the first publication. So the whole time period ideally should be equally represented. Also, according to author's gender, there should be, if not equal number of male and female authors, but the female authors should be represented at least by 30% of the novels. And canonicity of the novels, or the number of reprints. It means that not only well-known novels that everybody knows in a certain culture and has read, but also some novels that have been written and forgotten after that. And also authors, there should be novels written by authors that are represented in the corpus with only one work, and also novels represented by authors that have novels in this corpus, 3 novels. So that this has also to be taken into consideration when choosing texts. What now to say something about the annotation of ELTE corpus. All texts in ELTE comply to EEI XML format. And there are 3 levels of annotations. Level 0 expects only basic encoding. What is basic encoding? For instance, text for paragraphs. Level 1 is richer, and there can be some other tags also, for instance, for foreign words, for titles, for quotations, for separate lines, etc. Level 2 is the richest format, and it consists of morphosyntactic encoding and named entity annotation. It was recommended that 7 types of named entities should be recognized: persons, locations, organizations, events. It's not title, it's work. I made a mistake here. It's the titles of some works, roles, and demonyms. It doesn't depend what level, in what levels certain novel is. All of them have metadata stored in TI headers. And what is the status of LTEC near the end of the action? There are presently 10 complete 100 novel collections, and among them is Serbian. There are 4 incomplete collections with more than 50 novels, and 3 incomplete collections with less than 50 novels. And when it comes for the collections at level 2, here the situation is varies more. We have only one full morphologically, morphosyntactically annotated collection with full set of named entities. That means all 7 categories, and that's Portuguese. There is one full morphosyntactical annotation collection with full morphosyntactic annotation, but only a subset of named entities. That's Slovenian. As for Serbian, we have annotated lemmas and part of speech and full set of named entities. Then there are several, for several languages, full morphosyntactic annotation, but no named entities. Also, there are part of speech annotation and lemmas, but no named entities. And there are also some, for some languages, no level 2 has been yet produced. But before the end of the action, this can still change both for level 1 and level 2, because research groups are still working. And how did the preparation of Serbian LTEC go? The building of the Serbian sub-collection was rather challenging. And why was it? Because first it was necessary to produce the list of 100 and plus Serbian novels from the chosen period. And why was this challenging? Because for the Serbian language at that time period, the novels were not so frequently written as for some great languages, to call them like that, like English, French, German, etc. And most of these novels were not in the digital form. When I said most of this, I think mostly for those that were not so popular novels that we all read at some time in our life. Novels that were digitized were either not available or were not digitized properly. For instance, they didn't have any metadata, so we didn't know what was the print source. So at the end, it means that hard copies had to be retrieved in libraries, then the OCR has to be done, and that was followed by several steps of correction. And finally, TI tags and headers had to be provided. For the preparation of level 2, the existing tools were used and some new were prepared. For tagging and lemmatization, new taggers were trained for these specific tags, and you already heard about it. For name entity annotation, we used first the upgraded rule and lexicon-based named entity recognition and annotation system that was fine-tuned for each novel. And the annotation of a subset of novels was manually corrected to produce a training set. And on the basis of the training set, the new named entity systems were trained, and you heard about that already. And there has to be some acknowledgements. Who is the core team of the researchers? Persons you already met here: Ranka, Branislava, Mihailo, Milica, and Cvetana. And we had the great help of libraries, especially University Library Svetozar Marković, National Library of Serbia, Library of Matica Srpska, and Private Library of Cvetana and Duško. And we had the help of a number of volunteers. In a total, 25 PhD students and master students from the Faculty of Philology, and also volunteers of the Yertex Society. They read, corrected, and annotated novels. And special thanks go to the most persevering readers, Professor Duško Vitas and Ivan Obradović. And who can use LTEC? The LTEC collection in all its format is open and free for use for researchers and general public. Conditions of use with attribution are given in TI headers. And where can LTEC be found? The last release of LTEC can be reached through Zenodo. At the end of the action, all sub-collections will be published on GAMS, which is a system produced by the University of Graz, and also some other platforms. And the visibility of LTEC. Various platforms exist for different users. If you want actually to read these novels, then you should go to the Udaljeno čitanje at the University Library of Svetozar Marković. For close reading, you should use digital library called Aurore, where you get concordances of particular text that you choose to analyze. As a corpus, you can use it on No Sketch Engine or Unitex Corpus Processing Suite, which is a local application. For distant reading methods, you can use TXM for textometry, also as a local application. What also helps visibility of CERT is its presence at Wikidata. There are presently 190 novels in Wikidata with associated items for the first edition, digital edition, and the electronic editions. 100 of these novels belong to the basic set, and 19 or 20 to the extended set. Always new novels. These numbers are not correct because always there are some new novels that emerge. 2,100 statements were automatically added in Wikidata using powerful tools, Open Refine and Quick Statements, and information from novels headers. And main characters and locations in novels were also added in Wikidata using extracted named entities, person, and location. So we added manually 122 different locations and 877 main characters from 65 novels. And what is the benefit of data in Wikidata? Well, benefits are many, but the use of Wikidata query service enables the presentation of different types of visualizations, for instance, number of authors, timeline visualizations, etc. And some of them can be reached through this website, given the address is given here. One release of LTEC is already on European language grid, as you can see here on this screenshot. And at the end of the action, the whole corpus and the Serbian sub-collection in all its forms will be part of this European language grid. Of course, if you want to read more, there are some publications here, and I draw your attention especially to this special issue of Infoteca, published as a second number of 2021, where all articles are devoted to this Serbian subcollection of LTEC. And thank you. Well, now I would like at the end to draw your attention to the chat, where there are not many questions there, but there are a lot of information and reactions from the audience. So please go there and check them. Also, I would like to say finally that this last set of presentations were from, as you saw, from the different faculties of University of Belgrade, but we are all also connected through the our Society for Language Resources and Tools, YERTEH, and I would like to invite you all, if you are not already the member of that society, to become the member of that society, because I believe that we all here share same interests and goals, and those goals are to produce more valuable resources and tools for Serbian. Very soon we will have our General Assembly, and we will be free to send the invitation to all those that are present today at this presentation to the General Assembly. So we have a few more minutes. Maybe somebody would like to join, not through chat, because we have time.
Maybe everyone can put camera on to make
Yes.
picture.
Yes, and it would be nice if present here can make can be seen now, so that we can make a nice common screenshot. And of course, if you want to ask something, please be free to ask, because we have some more minutes left.
Oh, nice.
Mhm.
Professor, can you take that will be great. Wow.
Mhm.
Ja, czekaj.
Mhm.
Czekaj. Wait.
Almost similar to that. Mhm. Okay, Ranka has taken our common photo. It's needless to say that it would be nice if we could make such a photo in person and not like like this. But on the other hand, I see that not some, but quite a number of attendants were not from Belgrade, so probably they couldn't be with us anyway. It's good to be connected, at least remotely. Yes, also as I have mentioned, our YERTEC Society, you probably know if you have visited our site that we have regular seminars every semester with some very nice talks. We had really very interesting talks in the past. And especially now that we are getting used to this remote connections, it's not necessary that somebody is actually in Belgrade to come and present. It can all be done remotely. So if you would like, we encourage you, if you have something interesting to share with all of us, we would really be very happy to have you as a presenter. You can write either to my email address, to Ranka's email address, Branislava, Yertech, whichever address you use, it will be good, and we'll be happy to see you again as a lecturer at our seminar. Of course, if you couldn't remember now to ask something, but think about something that you would like to ask after, please also write to us, and we will be happy to answer any questions you have, and as well as we hope to stay in contact in any way, to stay in contact and to all work together to this same goal, and it is the better representation of Serbian in the digital world. And with this, I think that we can say goodbye now, at least for today. Goodbye, and thank you all for being here today.
And thank you, Svetlana, for joining us and organizing this event.
It was my pleasure.
A silent clap, silent applause.
Thank you.